Hiya, Mick here, and today we're looking at trig pillars and what they were actually used for. The original set of trig pillars were used to map the country using triangulation back in the 1800s. It was the most accurate method of mapping in the world at the time. They decided then to go back and remap the country back in the 1950s and added quite a lot of trig pillars to the set they already had there. So how did it work? On our triangle we have 3 points, so we'd send a team out to each one. With them they'd bring an instrument called a theodolite, which is able to measure the difference in angle on, well, the horizontal plane and also the vertical plane, so you can tell what angle somebody is above you. But we'd also send out a very bright light, so when the light was turned on, the theodolite could measure the angle between the lights on the other 2 points of the triangle, but also the height difference as well. But to start all of this off, they needed a baseline. So the baseline they chose was up in Lough Foyle. They measured a distance of 16 kilometres on the shores of Lough Foyle from Ballykelly to McGilligan Point, and they spent 60 days doing this. They used what's called a Colby bar. It was made from iron and brass, so it wouldn't expand or contract so much. But on the day, they would take the temperature and they could apply that to their calculations just to make them that little bit more accurate. From this baseline then, they needed to choose a third point. They used Slieve Schnacht in Donegal because they were able to see it from both points on their triangle. So I'm going to attempt to use trigonometry to see if I can work out how far away Slieve Schnacht is from the 2 points that we were given. We already know our baseline is 16 kilometres long. I'm going to use just a protractor to measure the angles there at the base. It would have been the theodolite back in the day, of course. First of all, I know the 3 angles in a triangle all add up to 180 degrees. I remember that from my school days. I've measured the purple angle as 68 degrees, the orange angle 72 degrees, so that gives me the blue angle as 40 degrees. So using the 3 angles plus the 1 side length that we know, we're actually able to work out what the other 2 side lengths are. I'm going to use a calculator to help me out with the calculations. Using the formula A over sine A equals B over sine B equals C over sine C, I can add in the values that we have. So I've calculated from that then that side B is 23.1 kilometres long, and side C is 23.7 kilometres long, but we better have a look back at the Ordnance Survey map and see if my calculations are correct. So for side B, it was actually 23.4 kilometres long, so it's 300 metres out. And side C is actually 24 kilometres long, so again 300 metres out. But I'm pretty happy with that, seeing as I'm just using a protractor and a piece of paper. I didn't measure the height difference, because really I'd want to be on that baseline with the theodolite to try that out, but maybe that's a video for another day.